All right, so since we're discussing the concept of circular motion, it is pretty important to discuss the concept of centripetal force, and we can actually start by actually giving an example. So first of all, we can have our attempt to draw a sun. So this is the sun, and then we can draw the planet Earth right over here, and we know that the planet Earth is revolving around the sun. So it is not exactly, but you can assume it to be in a circular motion. So we can observe the Earth to be revolving around the sun in a curved path, right, like this. And we know that by the concept of gravity, we know that the sun is actually pulling the Earth towards itself. It is attracting this mass. So we can see that there is a force of attraction that is pulling the Earth towards the sun, right? So the main question is why is Earth not ending up getting, you know, just getting, uh, just hitting the sun? Why is Earth not just ending up hitting the sun and bumping into the surface of the sun if the sun is really pulling the Earth towards itself? Why is Earth still revolving around the sun and not really going and hitting the sun? Why is this happening? Is because the Earth already has a tangential velocity that is tangentially acting to that is acting tangentially to the radius of the force of attraction from the sun, right? So Earth wants to go in this direction. This is the vector of velocity of the Earth wants to go in this direction. So if there is no attraction, the Earth will actually exit the orbit and will continue to go in this direction. And the force that the sun is pulling the Earth with is acting in this direction. So we know that this is a case of multiple forces acting on an object. So we need to find the resultant force. And the resultant force that we find is actually comes to be in this direction. And for every single point, you can plot the similar two vectors, and the resultant will actually be be following a curved or circular path here that we can see in these green arrows. So the motion or the overall the final net motion of the Earth would be a circular motion, and the Earth would actually be traveling in a curved uh, path, right? So what is this force of gravity? That is, this is basically the attract force of gravity, which is causing attraction. But particularly if we want to talk about this force, this force in anything that is actually having circular motion, the force that is actually attracting that object in circular motion towards the center of the circle is called the centripetal force. It is the force which actually causes an object to revolve around a central point. So the centripetal force is the reason that the Earth is not really exiting the circular orbit that it is having a fixed circular orbit that it is having around the sun. So it is precisely not circular, but at this level we assume it to be circular, and it is precisely a little bit elliptical. But it doesn't really matter. In order to understand centripetal force, you can assume the path to be perfectly circular as well, right? So if the centripetal force did not exist, then the Earth would actually exit the orbit and will go in the direction of this velocity vector, right? So centripetal force is basically the force that always acts towards the center of the circle. No matter Earth is at this point or this point, it will always act towards the center of this circle, because the source of attraction is lying right there in the center, right? And it is the reason that the thing is revolving in a circular path around the central point.